This is section 1.3, solving quadratic equations. This should be kind of tied in with 1.2 in Sullivan. But this is quadratic equations where your answers are going to be complex, not real. And so this is still the quadratic equation. A and B and C is still used in them. So it's the same formula that's applied. The only difference is that the discriminant will be less than 0. So back in 1.2, the discriminant was positive. Here the discriminant will be negative. And so therefore there is the imaginary unit to be considered. So the imaginary unit is I. I is when you have the square root of -1. That's called the imaginary unit. So every one of these problems in this section will probably have that going on. So x squared plus 5x plus 8 equals 0. So just like we did back in 1.2, you let a be 1, b be 5, and c be 8. So those numbers stay the same. It's just that when you did the discriminant, it's going to turn out to be a negative number. So x is equals to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So the opposite of b is -5 plus or minus the square root of b squared, that's 5 squared, minus 4 times 1, because that's a, and c is 8, all over 2 times a, and that's 1. So you get -5 plus or minus the square root of 25, 5 squared, minus 32. And 2 times 1 is 2. But notice 25 minus 32 is a -7. -7 is less than 0. So that's why I know it's going to be complex. So that's going to be -5 plus or minus the square root of -7. Now on the problem with -7, you take the square root of it. That is the same thing as taking the square root of 7 times the square root of -1. And remember what I said about square root of -1. That's I. So the square root of -1 is I. So this becomes the square root of 7 times I. So you get -5 plus or minus the square root of 7i divided by 2. Now the only thing is about form. This is just, most teachers want you to put it in a certain form, and so complex solutions have to be put in the form of a plus or minus bi, which basically means the number that does not have an I needs to be separated from the number that does have an I. That's probably the easiest way to explain it. And so -5 has plus or minus the square root of 7i over 2. -5 over 2 is the real part of it. So it's -5 halves plus or minus the square root of 7 over 2 times I. But you got to understand, -5 halves plus the square root of 7 over 2i is one solution, and -5 halves minus the square root of 7 over 2i is the other solution. Just like we did in 1.2, I told you there would be two answers for these things. So the thing about complex solutions, though, is the solutions are what we call conjugates. The conjugate of a plus bi is a minus bi, not to be confused with the opposites. So the conjugate is the bi's term. So the conjugate of a plus bi is a minus bi. If it was the opposite, it would be -a minus bi. And that's the opposite, not the conjugate. So, but anyway, so those are the two solutions. And these are numbers here. You definitely can't tangibly feel what those numbers are. So, but those are the numbers that work. So if you plug those back in into this, it would be pretty tough. Now this one right here, x squared plus 16 equals 0. So in this case, a is 1, b is 0, and c is 16. Now I know some of you guys will probably sell this, and you're like, well, I will use something called the square root property. That's what it's called, the square root property. This tells you how much I have used the square root property. I don't use it that often. Some of you guys will probably go, with the 16, I'm going to take the square root of both sides, and I'm done. Yeah, you could do that. But I like to be consistent. So these little exceptions here and there are all nice little shortcuts of how to do a problem. But when you're teaching a class like this, you just want to be straightforward and have one thing that fits all. You find ways to explore later. And so right now, I'm just going to be consistent with the formula. So x is equals to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So the opposite of b is -0 plus or minus the square root of 0 squared minus 4 times a, which is 1, times c, which is 16, all over 2 times 1. So you just plug the numbers in. And again, like I said a while ago, if you don't have the formula down right, it's going to be wrong. So you just got to be careful with those. So negative 0 is still 0, so it's going to be plus or minus. 0 squared minus 4 times 1 times negative 16 is actually going to be negative 64. And of course, 2 times 1 is 2. Now, negative 64 is the same thing as 64 times negative 1. And so taking the square root of negative 64 would be the same thing as taking the square root of that. And so that's going to be plus or minus 8i divided by 2. Because the square root of 64 is 8. And so the final answer, plus or minus 4i. So if you notice this one does not have a real part. It just has the imaginary part, 4 and 4i and negative 4i. So, but that is the answer. So plus or minus 4i. So like I said, this is kind of the same thing as 1.2. The only difference between 1.2 and 1.3 is the solutions, how they look. The 1.2 solutions, when you're dealing with the quadratic formula, will be real. They don't have the i's attached. So if they say find the real solutions in 1.2, and the answers turn out to be complex, you would just say they're not real. So I can't. So those are kind of nice, because if the discriminant turns out to be negative back in 1.2, then you just throw the answers away if they turn out to be imaginary. And unfortunately, in this section, if they say find the solutions in this section, the complexes are now available, and so they're expecting the i's if they have them. So you can't say that in section 1. So what I'm getting at is, when back at 1.2, there might be some problems that you have that you would say there is no real solution. But you can't say that in 1.3 because you've got the complex solutions to deal with in this section, unlike back at 1.2. So this section only has one part to it, and I don't think I'm going to do any more problems with this one. It's pretty straightforward following 1.2. So, thanks.